Good evening, students. So the second periodic properties we are going to study today is ionization energy or ionization potential, which is denoted by IE. We can say that, or we can say IP also. We can say ionization energy or ionization potential. What is ionization energy? Now all these definitions you can see it is given in my notes. All these definitions, the notes which I have given to you. You see the notes, but once again I am telling you. Listen carefully. It is the amount of energy required. It is the amount of energy required to remove an electron from the outermost shell of an isolated gaseous atom. What I said? It is the amount of energy which is required to remove an electron. For example, suppose we are having an element M. We are removing an electron that is E minus. So what is forming? It is forming a cation. So again I repeat, it is the amount of energy required to remove an electron from the outermost shell of an isolated gaseous atom. That is an atom. From an atom, what it? Isolated means single atom. You can say that. So in gaseous atom, why it is gaseous atom? Because in a gas, the atoms are far apart from each other, so it is easy to remove an electron from it. So that energy is known as ionization energy. So it is amount of energy required. Required means ionization energy is positive. Alright, this unit is what? Unit is electron volt. We can say that. Electron volt. Unit is. Achha. What is the relationship between electron volt and joule? Alright, because electron volt means 1 electron into 1 volt. 1 electron into 1 volt. The charge of 1 electron is 1.602 into 10 to the power minus 19 coulomb. And 1 joule is, that is 1 volt is 1 joule per coulomb. 1 volt. 1 volt is 1 joule per coulomb. We can say the coulomb cancel. So 1.602 into 10 to the power minus 19 joule. That is 1 electron volt is this much. We can say. So what you find is that, again I repeat, it's the amount of energy required to remove an electron from the outermost shell of an isolated gaseous atom. And we measure that particular value in terms of electron volt. And these are relations between electron volt and joules. We can say that. Now we will see when we move across the period what it happens, and when we come down the group what it happens. Yesterday we have studied that is when we move across a period atomic size decreases, and when we come down the group atomic size increases. Why atomic size decreases across a period? Because it is affected by the nuclear charge. Because nuclear charge increases. And down the group, why atomic size increases? Because down the group number of shells increases. For that particular purpose, atomic size increases. Now, what I said you, we are going to study about ionization energy. So again, same thing. I am taking second period. We can say that the second period, that is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And here we are having down the group sodium, potassium, rubidium, cesium, and another one is there, that is francium. 1, 2, 3, 4, 5, 6, above which hydrogen is there. We can say that. So what do you find? When you are moving across the period, nuclear charge is increasing. Okay. So atomic size is decreasing. Now here you are removing 1 electron from it. Alright. Here you are removing 1 electron. Some ionization energy is required. Now here when you are removing 1 electron, listen carefully. When we are removing 1 electron, what happens is that the remaining, that is electrons, pulls, that is what you can say, the nucleus pulls the remaining electrons strongly towards itself because nuclear charge increases. Here in case of beryllium, when you are removing 1 electron, then that is the nucleus pulls the remaining electron strongly towards itself because the nuclear charge is increasing. So when the atomic size is decreasing, will it be easy for you to remove this electron from beryllium? No. So in the same case, in the case of boron, when you are removing 1 electron, same thing. Atomic size still decreases further. That means when you are moving from left to right across a period, nuclear charge increases. That means atomic size decreases. The electrons are coming closer and closer to that of the nucleus. So hence it becomes difficult for you to remove the electrons. So due to which what we can say, ionization energy increases. Again I repeat. When you are moving across a period, nuclear charge increases, atomic size decreases. Here you are removing 1 electron. Got it? Because 1 electron, then the outermost shell. Here 2 electrons, then the outermost shells. When you are removing 1 electron, after that the remaining electron is strongly pulled by the nucleus because the nuclear charge is increasing. Due to this reason, it becomes difficult for you to remove what you can say the electron from it. So due to which what you find is that the ionization energy increases. Now when you come down the group, ionization energy what happens is decreases because the number of shells increases. You are going far away from the nucleus and you are going to remove the electron from the outermost shell. You are going to remove the electron from the outermost shell. When you are going to remove the electron from the outermost shell, that is atomic size is increasing. So it becomes easier for you to remove the electron. For example, in lithium, this is the atomic size, let us say. This is for lithium. For sodium, this is the atomic size. It will be bigger because sodium has got 3 shells. For potassium, the atomic size is still bigger because it has got 4 shells. So here what do you find? That is the distance of the nucleus is increasing. So when the distance is increasing, that means you are going far away from the nucleus. That means atomic size is increasing. And hence it is easy to remove the electron from the outermost shell. So as it is easy to remove the electron from the outermost shell, so ionization energy decreases. Ionization energy decreases. So across a period, as nuclear charge increases, ionization energy increases. Down the group, as number of shells increases, it becomes easier for us to remove the electron from the outermost shells. Ionization energy decreases. We can say that. So this is about what you can say, that is ionization energy, we can say, or ionization potential. Now, next, so accordingly, if you think of in a particular, that is in a group, cesium will have the lowest ionization energy, we can say that, and fluorine will have the highest ionization energy, or I should say neon will also have still the highest ionization energy, because in a case of neon, the outermost shell is also fully filled, we can say that. Clear? So the next one we will come to is the third one. Electron affinity. The first two is over. Electron affinity or electron gain enthalpy. So electron affinity or electron gain enthalpy denoted by the letter delta Eg. Electron gain enthalpy. It is just opposite of ionization energy. Electron gain enthalpy is what? It is the amount of energy released. It is the amount of energy released for the removal of an electron from the outermost shell of an isolated gaseous atom. It is the amount of energy released for the removal of. Now here we are, that is in the previous case what it was, the amount of energy required to do an electron. Here it is the amount of energy released for the addition of, sorry, I am very sorry, it is the amount of energy released for the addition of an electron for the outermost shell to the outermost shell of an isolated gaseous atom. Here you are going to add an electron. I am very sorry, I said it is amount energy required to remove an electron. It is not remove, it is the amount of energy which is required is, okay,